70 million years ago in the late Cretaceous period, a small white dinosaur approached the lakeshore, appearing to want to drink water. But in fact, this was not the case. It was testing the water temperature because this large lake was actually their primary living environment. This duck-like dinosaur was Halscaraptor, spending most of their time living in water or by the water's edge. This small dinosaur, about 60 centimeters long, was a swimming dromaeosaurid with webbed feet that propelled it quickly through water, while its short flipper-like forelimbs helped it steer. Halscaraptor possessed characteristics allowing it to be amphibious, and its series of spectacular hunting maneuvers in the water thoroughly amazed the Deinocheirus watching from shore. The young Deinocheirus, always eager to try new things, also walked into the middle of the lake. Given their massive size, they naturally couldn't dive underwater, but their 2.5-meter-long forelimbs now proved extremely useful. They would detect fish movements, identify targets, then violently slap the water with their huge forelimbs. The powerful force sending some unlucky fish flying ashore where they could be caught. The captured fish surely couldn't understand how this completely toothless dinosaur had taken up fish eating as a habit. Yet the truth was that eating fish was just one of their basic survival skills. When vegetation was scarce and food shortages occurred, they would even resort to eating other small dinosaurs in desperation. Having no teeth at all, it could only swallow the fish whole, a feeding method that shocked passing ornithomimosaurs who couldn't bear to watch this primarily herbivorous giant's current behavior. After this highly successful fishing experience, the Deinocheirus seemed to develop an obsession with this fishing lifestyle, finding life by the water far more enjoyable than in the forests. The orphaned Deinocheirus survivor had grown significantly in size, its feathers becoming more vividly red. Scientists speculate that, like modern birds, dinosaur feather colors may have changed with age and maturity. This female Deinocheirus had now reached full maturity, and her primary mission became finding a suitable mate to fulfill the important task of reproduction. During the dinosaur era, they faced almost no survival pressures, and it was precisely this consistently strong reproductive capacity that allowed dinosaur populations to thrive successfully for 160 million years. At this moment, another Deinocheirus with blue neck and sail approached, a male individual. This color difference indicates their feathers serve visual gender differentiation purposes. The male Deinocheirus raised its head and extended its slender forelimbs, displaying a stunning courtship posture remarkably similar to modern birds' mating displays like peacocks fanning their tails, showing signs of convergent evolution. This behavior suggests that, like modern birds, dinosaur feather ornamentation played important roles in mating. The adult female Deinocheirus, seeing such courtship behavior for the first time, was quickly moved by the male's dance, and thus they became mates. Anyone who has incubated eggs knows oviparity also has great advantages. Large reproductive capacity, allowing many eggs to be laid at once, thereby increasing offspring numbers and reproductive success rates. It was precisely this reproductive strategy that allowed dinosaurs to dominate Earth for so many years. This Deinocheirus was now producing large numbers of offspring, arranging its eggs in a neat circle before lying in the center, using its massive body to heat the central position and provide incubation warmth to the surrounding eggs. Since Deinocheirus reached 11 meters in length, their nests needed to be correspondingly large to accommodate their enormous bodies. Through this method, Deinocheirus completely solved the problem of continuing their lineage. But this incubation style also brought them a very painful process. With the egg circle's diameter being too large, the Deinocheirus's huge body could only transfer heat to eggs near its abdomen, leaving other positions eggs receiving uneven heating that prevented proper incubation. To solve this technical challenge, the Deinocheirus had to periodically adjust its body position to provide proper incubation warmth to those unevenly heated eggs. These giant dinosaurs sometimes required 6 months to incubate eggs, while oviparity allows survival and reproduction under various environmental conditions. Its disadvantages are also quite apparent. For instance, eggs are vulnerable to predation and damage by natural enemies. Zanabazar, a troodontid dinosaur, proved to be an insurmountable opponent for Deinocheirus during incubation. Several Zanabazar appearing on the distant hillside were specifically targeting the Deinocheirus's eggs. Yet at this moment, the Deinocheirus could only watch helplessly as these largest known Asian troodontids eyed its eggs, powerless to stop them. Facing this approaching danger, the Deinocheirus still had to assume a defensive posture, hoping this might drive away the predators.